No, no. All right. It's okay, it's okay. It's fine, it's me, I did it. Okay, welcome. We have an hour and a half. This is the IETF 6TISCH workgroup meeting at IETF 96. Pascal is circulating the blue sheets. Thank you for signing them. And I don't have my clicker.
And when you come to the mic, please stay within this square. If you're not used to it, there's a square here. That's where you want to be, because of the meeting.
Pascal, tu peux appuyer next. Okay, so the IETF note well applies to this meeting and is applied to any meeting. Next slide, please. If you know of any IPR that we're discussing, whether it's yours or not, you have to disclose it. If you have any questions, read through the slide, read the documents it cites, and ask your favorite workgroup chair or AD. Next slide, please. As a reminder, we are taking minutes, and I thank Dominique, who's here, and Diego, who should be here, for taking minutes. We are recording the meeting, and presence is logged. All of this will be pushed to the meeting right after, to the mailing list right after the meeting. Next slide, please. Blue sheets are being circulated. Please sign them. Thank you, Dominique and Diego, for taking minutes. And thank you to Ines, who's somewhere here, yeah, to be the Java scribe. Next slide. This is the agenda. We are right in the first part. After that, we'll give you a quick update on the status of the working group. I don't think, and I hope it won't take 20 minutes. After that, we'll go through dynamic scheduling drafts. These are workgroup documents. Xavi will present the 6-stop protocol 01, and Diego will present the scheduling function 001 as well. Michael will then talk about security, and I understand you have some updated slides, so I'll do this as we progress. We have then some news about the ETSI 6TISCH 6-flow plug test that just took place over the weekend, and Margarita will be presenting those results. And then, time permitting, Satish will talk about SF1, also 01, which was published yesterday, but it's an individual submission. We then have 2 minutes for any other business. So before we get started, can you go back, please? We need to do some agenda bashing. Anybody here see something's missing or something they want to change, add, or remove? Please raise the issue now. Okay, I see nothing, so let's write in the minutes that the agenda is approved, and let's follow this one. First item, Pascal, for an update.
So quick recap on all the draft. I won't go through all this, and Diego, please take your seat. We need you for a minute. So we've got good progress on the 6-stop protocol and on the SF0 that will be presented next. And I have a slide for the minimal draft, but it's past the last call. The review by the Internet area is complete, and now Suresh is pushing it to the ASG. Next slide. So what's happening at Roll and 6-Low? So you know we were a party in the 6-Low RH adventure. The 6-Low RH draft was split in a coding dispatch, which is still at 6-Low, and a paging routing header, which is now done at Roll. So Roll both have done last call, but Roll is hung because the document, the 6-Low counterpart, has not progressed. So now we are actively pursuing the 6-Low piece so that it goes to the ASG as well. So what's missing now is the shape-out review. That's a technical thing. Then there is the backbone router. We'll discuss the backbone router when we discuss the ETSI plug test. The backbone router is a workgroup document at 6-Low. It's important for 6TISCH. It's part of our architecture. And the backbone router draft is thick. It has really 3 pieces in it. One is descriptive, should be informational. And then there is what updates 6LOP and ND, RFC 6775. This is now being split in a different document. And finally, there is the backbone router proxy operation, which is really the core of the backbone router draft. And this will continue as it is. Next slide, please. A little bit of news about 6man. So 6man is tomorrow morning. 6man is finally pushing IPv6 into an internet standard. You know, there is these categories of standards. So making IPv6 an internet standard is a big step for the internet and for the IETF. There are 3 drafts which are being BIST 2460, which is IPv6. Then you've got the architecture and you've got path MTU discovery. So there is an interesting discussion for this group about header insertion, which is happening on the 6man mailing list. And you know that most implementation of REPL do actually insert headers as opposed to do IP and IP. Whether this is a good idea or not, whether it's lawful or not, is this discussion that is happening at 6man. Right now, the discussion is really what text should change from 2460 to the BIST, to the internet standard. And those who still want to do header insertion are fighting to keep the text unclear about whether you can or you cannot do it. Some other people would want to clarify that you can't, but then all those REPL implementations which do header insertion would be broken. So if you're interested in giving your advice on that discussion, please come to 6man tomorrow. Next slide. This is where we are versus our milestones. We are pretty much in line. The 6-stop sublayer is not yet passed last call and submitted to ISG, so we probably won't do this milestone in July, probably more in August. Suresh, we'll have to, there's a mistake in this list. Yeah, but that's not minimal, that's the 6-stop protocol I'm talking about. For the milestone, yeah. So for the 6-stop protocol, actually we renamed the draft, it's not 6-stop sublayer. So we have to work just to change the name that appears here. That's just, so apart from that, yes, we should promote this last call and promote the 6P protocol very soon now, I hope. Next slide. So where we're at now, well, the security discussions have been kicked off, as we promised last time, and Michael Richardson is leading this. He will present the security work as it stands now. And we keep this method that has proven itself over time of doing rapid circulation of document to code, open source code, OpenWSN guide, and then etc plug test in a loop, which we have done 3 times already, and it's kind of working well for us. That's pretty much it. Any question? So Suresh, you're telling us that minimal now is pushed to the ASG?
So I just saw a new draft before the meeting, probably last month sometime, and the idea is to get the IETF last call done before going to the ISG. So
for minimal?
Yeah. So it hasn't gone through IETF last call. Yeah.
Oh yes, it does.
No.
Working group, but not.
Oh, no, not IETF. I'm sorry.
Yeah, so it goes to IETF last call, and then it goes to the ISG.
Okay.
Okay, that's the plan. So so I got positive confirmation from Charlie on the draft. So I'm just going to go over the stuff, make sure all the reviews are addressed, and then send it off to last call. IETF last call.
Thank you so much.
Okay. And if there's no more questions, we'll switch to the next item. So Xavi.
Suresh, there's actually one more thing, and this is not relevant just for 6TISCH, but it's something much larger. One of the things that came up during a draft review recently, this was regarding the PTP, the Precise Time Protocol. So we are doing a MIB model for it. And one of the issues that came up was the copyright for IEEE documents in IETF drafts. So it's very unclear what the policy is. And so there's going to be a meeting tomorrow between the IEEE leadership and part of the IETF leadership. And I'm going to bring this topic up in that meeting tomorrow. So there might be some pending items there based on how that comes up with. So like approximate policy that I've been told is that if we quote more than 10% of the IEEE document, or we quote, I think the word was like substantial parts of the document or something like that, we need to apply for a copyright. And that's something that needs to get worked out. We don't know what that is. Okay, so that's like a potential unknown for quoting text from IEEE documents. And I know 6TISCH minimal has like some stuff like from the IEEE document. So that's probably something that could be like a more work. Okay.
Yeah. Charlie, maybe you can comment on the editing choices for minimal and how much. I mean, the idea was to remove exact copy paste, right?
Yeah. So we just review it, and I think Pat Kinney as well had a look to it, and we just try to say what we use from it, but we always point to the document for specific things that are exactly that.
So go ahead, the floor is yours.
Okay, so I will update you about the status of the 6TOP protocol draft. We submit version 1. Can you do next slide, please? We submitted version 1 recently. So this draft was adopted in the IETF 95, and we rename it from the sublayer draft to be the 6TOP protocol. And in this version that is already published, what we did is, following the discussions in the mailing list and in the work group meetings, we updated, or we did a clarification of what happens when there are concurrent 6P transactions. So I think now the text is very clear, and this part is pretty much stable. Next slide, please. So today I want to raise some discussion and some points that we think we can improve, and these things and these points derive from the outcomes of the recent plaque test. So we've been doing interop we have this protocol implemented by different vendors, and we've seen that there are points that need to be improved. So I will go through it. I have some proposals, and maybe I want some feedback from the group, so if we can move forward with the draft. So the first thing is we have a 6P count command. Is used by a node to ask its neighbor how many cells you have in the scheduled that I scheduled to you. So this command returns the number of TX cells, the number of transmission cells that one node has to its neighbor. This functionality is fine, is good, but we think that we can extend that to have a better status functionality. Instead of only getting the TX cells, we may want also to have the RX cells. So how many of the cells I have in the schedule are RX in my neighbor's schedule. So we propose to change the name of the command from 6P count to 6P status, and then it will be a little bit wider. And then we will need as well to modify the content of the header, but it's not a big thing. The second thing we found is that the 6P list command does not paginate. So if when we ask our neighbor to list the cells we have to it, if it has more than the number of cells that fit into a packet, we have a problem. So we saw that we can add pagination here and ask cells starting from an offset and ask for a number of particular cells. It's not something very big, but it's an improvement that we think will make sense. And then the final thing is we detected that we need a mechanism to detect that the schedule between a node and its neighbor is consistent, because it can happen that two nodes, for some reason, they disconnect, and maybe one timeouts the cells in the schedule and removes some of them, but the other one still doesn't time out. So when they come again together and they start talking, maybe their schedules are not consistent. So we need a way to at least identify that and provide a mechanism to restore the state or reset or enable another component to decide. Next slide, please. So for 6P count, this is the proposal we have. We propose to convert the 6P count to 6P status, and you see here this is how it is now, the header of the packet or the command, and then we propose to have the result of the count, the cells that are from A to B plus the cells that are from B to A. And the status function will return the number of cells that we have in the both schedules, on the transmission side and on the reception side. And we have these fields, we call them generation. I will talk about them when I talk about the consistency. This is basically to keep track of the version or the generation of the schedule in both nodes and detect if there's a problem of consistency. Next slide, please. So the list command, this is the current header for the 6P list command. The proposal again is to add this offset a number of cells that we request in the header, so we can say, okay, I list a particular number of cells that are starting from cell 10 or starting from cell 20. So it's basically a simple pagination protocol. The proposal is as well to add another command. We have now one list, and we propose to have two list commands, one that returns the cells that are scheduled from A to B, and another one that are scheduled from B to A, being B and A two neighbors. In that way, we can have the list of the Rx cells and the list of TX cells. Next slide. Yeah. Okay, so this is more or less the same, and what we also propose is that to add another error code that whenever we issue a list for a number of cells that do not fit into a packet, we get a response code saying no resources. This means that the amount of cells that you are requesting do not fit into the payload of the packet, so maybe you have to retry with a smaller number of cells. Next, please. Consistency. The problem here is that I can have two nodes, and as I said, they have been scheduling one to the other, and they keep evolving their schedules, and for some reason one disconnects, for some reason one loses connectivity, and the other one timeouts some of the cells it has in the schedule, and it deletes them, or for some reason there's a policy of the scheduling function that moves them. So how we can ensure that when this node that has been disconnected for a few moments, how we can ensure that when it rejoins, its schedule consistent. So the idea here is to detect inconsistencies and enable the scheduling function to take a decision. The most simple decision is that if I detect an inconsistency, I issue a clear. I clear the schedule, and then I start again. But this will be open to the scheduling function. Mm-hmm. So we would not say what to do. We just want to provide a mechanism to detect that something is not correct. So the idea here is to cut the sequence number that we have already now, and which is 1 byte, to cut it in two parts. One part will be still the sequence number of the packet. The other part will have a kind of counter or a generation counter for both sides, for the cells that are allocated to transmit from A to B, and for the cells that are scheduled to transmit from B to A. And this will be, we call it lollipop counter. It will have a value of 0 when these two nodes never talk. And once they have talked and they have set some cells in the schedule, it will roll up between 1 and 2. So it will be like 1, 2, 1, 2. So it's just a 1-bit counter. And we reserve number 3. With that, we will be able to detect in any of the commands that we issue, like a list or count or add, we will detect if the nodes have inconsistent values for these counters. Next slide, Pascal?
So,
Yeah.
Thomas Otena, I have a clarifying question. You said before that it's up to the SF to decide what to do when it detects an inconsistency, and one of the things it could do is a clear. Is it clear? Does the clear necessarily mean that the node requesting it clears as well? So I have mode A and B. Mode A realizes its state is inconsistent with that of its neighbors, and it issues a clear. What needs to happen? Must A clear its schedule and or B?
Yeah, that's a good question. Yeah, so I think both have to clear.
Okay. So this is something I think that you noted as well, that currently the draft doesn't say it, and so in the implementation that they put together, the clear did not clear the local schedule, and so so this is something I think that we need to add.
We have to write it. Thank you. So here I put an example of how it would work. So we assume each device have let's say it's 2 counters, local counters. This doesn't fly over the air, and these counters, when let's say node A sends a request to node B, saying, okay, I want to add 1 cell, it puts in the header of the packet its local counter for TX, because the add command always allocates TX cells. So at the reception, the node B sends back the success, assuming it succeeds on allocating the cells, and then it goes back an ACK. At that point, these 2 nodes will increase because both of them allocate a cell in their schedule, so both of them will increase these counters. And for node A will be the transmission counter because it allocated a TX cell to that direction, and for node B it will be the RX counter because it allocated a reception cell from node A. Next slide, please.
Can you speak further from the mic?
Yes.
Because there is some echo.
Okay, sorry.
Or move it just down a little bit.
Yeah. So how to detect a collision? We have, imagine that we have node A issuing a status request to node B to know what's the status of the schedule. And in the status request, node A, and this is wrong, node A indicates in this field its TX counter and also its RX counter. Then when this gets to the other side, the node B compares whatever it comes in the packet, these 2 fields, with its local counters. And if they are not the same, it has to return an error because there's an inconsistency problem here. So it returns a response code that says that the generation is not correct, generation error. So then node A can decide what to do. Next slide, Pascal, please.
Thomas, a question? No?
You have a question?
So Thomas Otena, I have a question. This is essentially a 1-bit counter that just toggles. Is this enough in terms of width?
I think it's enough because a node cannot send 2 transactions before finishing them. So if I'm in the middle of transaction line, I try another one, then it will fail.
Okay. So this works because of the requirement that nodes do not have concurrent transactions with the same neighbor.
Yeah.
Okay.
Pascal, so since I was one of those who suggested this sort of change, I'm very happy that you're taking that into account. I have one last question about this flow is, I've got this device, it just wakes up in the void, it has forgotten everything. But there is 1 or more routers around which have state about this device. And this flow seems to impose that I know who has a state about me, so I can ask him where he is. But if I just wake up out of the void, I just don't even know who around me has a state about me. So is there a way to just broadcast something? I'm just alive again, but if you have something about me, let me know because I don't have a clue. You see this basic problem.
Yeah, I haven't thought about that. There's maybe some discussion here.
Are there any questions about this? Now, a little bit of context. This is Thomas. These are mainly things that we realized during the plug test that were essentially broken in the 6P protocol. If you had many cells and you did a list command, and there happened to be too many cells for your one frame to respond to full list, because we do not do fragmentation at the 6P level, it just didn't work. So that's why we decided to present this here. These are outcomes of the plug tests, and thank you, Charlie, for putting them together so fast, but I realized that these are things that we have not yet discussed on the mailing list. So I would recommend, would ask you to start discussing and describing this on the mailing list so we have feedback. It's a little bit unorthodox to describe stuff at the work group meeting without having this describing on the mailing list, but I thought it was very useful because it comes from the plug test from last weekend. Any questions, any feedback from the implementers? Is this something that is complicated? Is this something that is easy? Do you see any problems with these changes? I think I'm looking at you. No, okay, not now, okay.
Which probably means that the work item which was in orange in our plan will move a few months, right? We won't be done by July, right? July being now. Correct. So we probably need to move this work item to September or something like this before we have time to experiment with this.
Is there, Charlie, are you waiting for what are you waiting for from the working group? You want feedback from implementers? Do you want feedback from? Is there anything?
I want. So you think about it. If you find that this is a problem or there's any issue on this proposal, raise it on the mailing list. And if you think it's fine, I will try to move forward. I want to be fast on this. Maybe I don't know, 15 days is more than enough to think about this thing. And if I don't get any point or any answer on whether you see any problem, I will just write this on the draft and push another version.
Any more questions? Okay, thank you, Charlie. Thank you. The next item, if I switch, is SF0.
This is supposed to work, but doesn't seem to work well.
Yeah, the little gray areas, yeah. Okay. So, Diego.
Right, just to see.
Okay.
Well, you better turn it this way.
Yeah, he can.
Okay.
Yeah.
Good afternoon, everybody. I'm Diego Duhovne. I'm the editor of this draft with the co-authors Alfredo Grieco, Maria Rita Batilla, and Nicola Accetura. Have been working on this draft for quite a long time. Although this is version 1 here, it's about the 8th version, and if we take into account all the other former versions we had before it was adopted. So the goal was originally called the on-the-fly scheduling function. It became this scheduling function 0, which is aimed to be the default scheduling function from the 6TISCH stack. So we have had many small changes, but that account for some different behavior of the scheduling function 0. And in fact, we have to follow all of the changes that happened on the 6P protocol during this time. These old changes came from IETF 95 and from Buenos Aires. And the following, what we expect for the future is to adapt to a new changes, of course, on 6P, and have many questions that are still open at the end. So we have first of all, on Buenos Aires, we propose to simplify the algorithm. We're proposing for the bandwidth estimation algorithm. And we are, since the application is not communicating us whenever it asks for more bandwidth. So we must measure, first of all, the current outgoing bandwidth usage. And then we know which is the new incoming bandwidth requirements from the other nodes on the line. So then with this estimation, we are calculating a new outgoing bandwidth, and then this is converted to cells. And this number of cells becomes the input for the allocation policy, which is here. So the cell allocation policy has changed a little bit. So we established another threshold. There was only a low threshold, now there's a high threshold too. But what's important here is the band that we have. So this threshold also defines when to reserve more cells or when to delete more cells. And in the middle, where we give a stability to the behavior of the scaling function. And also we add some over provisioning, because at the beginning we don't know how many cells are already used by the application which is running on the node. And then what we need is not to lose these packets because of the queue is growing on and queue is full. Yes, come back.
Yeah, please, Thomas Botene. I have a clarifying question. I never quite understood this drawing.
Yeah.
Okay, so I have scheduled cell, which is on the top,
Mm-hmm.
and then I have required cell, and there's one more.
Yes.
And I understand there's a threshold here that means if my required cell is almost the same as a scheduled cell, that I don't have to add.
Mm-hmm.
That's the idea, right?
Yes.
Why is SF0 at that position? Why isn't it to the right?
So
centered around the scheduled cell.
So if your required cells are more than scale C, that triggers the algorithm and adds more cells.
Okay.
Yes.
So okay.
Meaning add the two squares on the top, meaning that.
Okay.
Yes.
It's confusing. Sorry.
Okay.
Okay. I don't. So sorry. I really want to
Yes.
understand. So because I should understand.
You mean the two squares on the right of the scheduled cells?
Yeah. So
Yeah.
there's required cells with two squares.
Yes.
Meaning I need. I'm looking at the bandwidth I need to my neighbor,
Yes.
and there's very little. I have very little to say to that neighbor, so I only need 2 cells per slot frame to communicate with that neighbor.
Yes.
Right? I have a bunch more, so I remove one. I remove until I'm
Yes.
close to that. Okay. If my required cell is above the number of scheduled cell, then I
Yeah.
add. But again, the threshold here.
It's a low threshold. Yes. It's a band.
Okay. So if I read the threshold correctly, if my required cell is 6, yes, and I have scheduled 5, then I do nothing.
Mm-hmm.
But then I don't have enough bandwidth.
Yes. The thing is, we from growing and slowing down.
Okay. Okay. But does it make sense to have a threshold in the growing direction? Meaning, if I have less scheduled cells than required cells, I'm going to drop packets.
You have less. Sorry, can you repeat it, please? You have less scheduled cells than the required cells.
Yes.
So you have to add. But you are expecting to add afterwards. That meaning that you are having less cells.
Okay.
Yes.
So now my required cells here is 6.
Yes.
Right. In the middle required cells, I have 6. Right. If I have 5 scheduled cells, do I add or not? That's my question.
Okay. So that condition means that you need to pass the other limit in order to increase. That means you have to need at least 7, but at least 8, sorry, to increase.
Thomas. This is Nicola Citura. If you have scheduled cells which is 5,
Yes.
you will have the SF threshold which is shifted also on the left. So you will have to add cells.
Okay.
The initial situation is 8, right? I mean, this is what the threshold is.
Yes.
And the one thing which is not represented is if you ask for, if your final situation expected would be 7, it's not inside the threshold. So do you add? If I read this,
Yes.
if I want to go to 7, I have 8,
Yes.
and I want to go to 7, I will still add something. That's what
If I had 8 on,
I have 8, right? That's
yes,
that's
the schedule, yeah.
It's 9. Well, I can count, but I have 9.
Yes.
Okay,
9.
and I want so I want 8.
Yes.
If this is not represented, that takes it to the right of the threshold.
Yes, you have over provisioning there. Okay, you have to go really back to reduce
Right.
the number of cells.
But is 8 in this situation drawn here a do nothing, or is it a add one more cell? Because it's outside of the
8.
threshold. I mean, the threshold.
It depends. Those 2 cells mean
If, I,
the extra 2 cells on top of the threshold.
if the required cell is 7,
Yes.
it goes outside of the threshold, right? Because the threshold is right 7. So let's say
7.
8.
Yes.
So if my final situation is 8,
Yes.
which is on the right of the threshold,
Yes.
do I do nothing or do I add one more cell? I understand that I would add one more cell.
If you require 8, and then
So the beginning is 9, right?
yeah,
And I want the required cell is 8.
8. Yes.
What do I do in this picture? Is it a do nothing or is it to add one more cell?
If you start with required cells 9 and the
This is Nicola.
the schedule cell 8.
If you have 8
But I can
cells,
get
you add
you-
cells.
Yes.
You have 9 scheduled cells. That's
Yes.
the drawing. It's like that.
If you
You
have 9 scheduled cells and you
Yes.
have 8 required cells, you add cells. You add 2 cells.
You add cells. So
Yeah.
you already have too much and you still add.
Yeah.
I mean, that's how I read this too, but I wanted to clarify it was the desire.
Yeah, okay. I get it from yes.
So you have always 2 cells more, for instance. But
Okay,
this can
so-
be configurable, this
Yes.
2 cells more. or
Okay,
3.
so the goal, the threshold being on the left of the scheduled cell is to always have 2 more than you need.
Exactly. Yeah.
That's what
Okay.
it's for. So
Okay.
yes,
That's
if that's what.
That's the
clear.
minimum. Yes, that's over provisioning that we are.
If you could draw
expecting.
just that case of 8 as well,
Okay,
you
okay.
could clarify that.
So I have a suggestion from Dominique who's taking notes, and I'm relaying his suggestion. The SF0 threshold arrow
Mhm.
should only be to one side, right? It shouldn't be bidirectional. It
Okay.
should be from the current situation and less.
Okay.
And what I would recommend you do is you update this figure and you turn it into 3 figures, 3
Okay.
sub-figures.
Three conditions. Okay.
These are the scheduled cells, these are required cells, there's this threshold, so it's clear that I delete. And then a second figure where, you know, because I don't know this SF0 threshold column there, to what case it
Okay.
corresponds. But so, my main point is that we should always over provision cells,
Yes.
right? We should always have too many. How many too many?
It's
You know, it's
configurable.
configurable,
Yeah.
but we should never have too little. So
Yeah.
do you confirm that this
Yes,
is the
the
case?
idea was
Okay,
over
so it's just
provisioning
a-
to.
So
yeah,
just
always.
a clarification thing.
Yes.
Okay, thank you.
Next, okay. So as you mentioned before, once the estimated bandwidth is converted to required cells, and there's no direct link except for the packet delivery rate of each of the cells. So there's, if you have 10, bandwidth of 10, okay, then we map to maybe 11 cells or maybe 20 cells, depending on the packet delivery rate of the cells we are selecting. And any relocation request from a neighbor, okay, so if we are relocating because we have different problems with the packet delivery rate, that means that we have new incoming bandwidth. Also, we trigger the bandwidth estimation algorithm again. So one another changes we have had here is working on the whitelist and blacklist process. The whitelist process, meaning that this is the number we do this exchange with through a 6 protocol with the neighbor, just to ask a number of cells. So here we say, okay, the cells we are offering, okay, we follow this process that select as a slot offset randomly, then verify that the slot offset is free, and then we have changed this, okay, we have added that we choose the channel offset randomly also. And destination node, it just receives the cell list and the number of cells that we require from that list. So the offer is always the same or more of the cells. And we then verify the offset is free. If it is, we allocate the cell. If it's not, we check the next cell from the cell list. That's only. On the same.
Next.
Yes. Okay. There we go. The blacklist, that's the opposite. Okay, where we have the list of currently scheduled cells. This is our list. Okay, the neighbor which is requesting cells, and the cells sends the cells which are already used. Okay, so the other node selects from the available cells in the intersection of the available cells from those nodes. So from that cell list and the number of cells requested, we select a random cell from the already empty cells we have on the other node. That way, we verify if the slot offset is not in the blacklist, and then if this condition is certain, then we allocate a cell. And this prevents the thing is this random requirement. You have a list of the cells we have already tested. So we finish someday, okay, to say, looking for the cells, not an infinite loop here. Yes. We not arrive to an infinite loop. Yeah.
There are multiple reasons why you would have a blacklist. One of them is administrative, because you want to reserve bandwidth for something else. Others are dynamic, like I know they have interference, cross-channel interference on the cells, and others may be very dynamic, like I have multipath interference, for instance. So yeah, I should blacklist for now. So basically, do you just expect that the blacklist logic comes from somewhere else and you just have this list? Or do you intend to provide mechanisms to establish the blacklist? I mean, where is it coming from, basically?
Well, we call it blacklist only because we're offering the cells that we have. So the ones that shouldn't be used by the other node for the scheduling.
Also, your blacklist is just a list of what you already allocated something else.
Yes.
So you don't have an external list of cells you should not be using.
No.
Because that will come, right? The controller, the PC, whatever, will have a list of cells it doesn't want you to use. Well, probably you won't have a bundle for them then. But dynamically, there may be cells which are found not to work well with a certain peer, and you want to make a blacklist for that peer.
Well, that happens on another algorithm that we have there, which is the relocation algorithm, which is the dynamic and comes after this. So whenever you find a cell which has a very low packet delivery rate, which is below 20% of the other cells which are allocated, then you move. Right. And then you are discovering dynamically which of the cells which are bad.
Do you blacklist that cell for some time, forever? Do you not blacklist it at all?
We don't blacklist because maybe it's a dynamic condition. Afterwards, you're going to be.
So the next allocation may just pick this cell again, right?
Since it's random, okay, maybe.
There should be a mechanism to list recently used things so that you don't pick it again.
A queue, maybe. They put in a queue, and whenever it finishes, okay, then we try again.
Not reuse the same sample as
Okay.
the so if you can.
Yes. So we have changed the timeout value that we had before to easier to understand, in fact, and easier to improve to implement this timeout value equals only to the time between the current cell and the next allocated cell only. So if we have no news until the next scheduled cell, okay, then we just cancel the operation we were just started before. That's the standard timeout value. And there we go. And that original timeout value, we moved it to the node behavior at boot, because this timeout value was calculated, sorry, by the maximum timeout value that we may have during the bootstrap process. So this is the idea to putting this timeout value here. This is the initial timeout value. So that's the change we have done.
Go ahead.
So we have updated the errors. Now we have a new error to manage from 6P, but we have to take that into account too. We renamed the RCBC, okay, now supports concurrent transactions. And we have a discussion on the mailing list about that. And then RC reset and RC error, okay, that's where we have changed the behavior only, very small changes on that. And about the RCBC, we have a proposal from Chin to use one bit for metadata to differentiate that we have no resources to process from an ongoing concurrent transaction, meaning that a node may have multiple neighbors which are asking for cells, and this request may be handled concurrently. And given this condition, where if we have to lock one of the transactions, lock the other transactions and keep only one alive until we have solved the problem. And yes.
Thomas, a clarifying question.
Yes.
I don't understand the two cases. No processing resources from
ongoing. Yes.
Yeah, please. Sorry. Yeah.
The no processing resources is only to the when the node is overloaded with some task, okay, some application which is taking too much time. And the ongoing concurrent transaction, it means that many neighbors have already asked for cells, and they have sent a list, but there may be a collision between the cells that are available from each of the neighbors. Okay. So given that condition, you are put in a wait state. Okay, you have to retry this this exchange afterwards. Yes.
So I think that no processing resources is.
Your name.
Sorry, Xavi Vila Susana. So I think that no processing resources is when you issue a request to the neighbor, and for some reason you ask for 3 cells and it only has 2, so it returns it cannot deal with that request. So you have your schedule full.
Now you have put that on the that's a new error that appeared on 6P, or that it was before?
It will return busy.
Return busy. Okay, but that's the idea. Okay.
Yes. Really, Thomas? That's not what I. So there's also the no resources.
Yes,
error,
that's
right?
the point.
But
Yes,
this is new now.
This is
This is
new.
new now. Yeah.
But I wasn't aware of it when I created this.
Diego, correct me if I'm wrong. If I may try and rephrase.
Yes.
The no processing resources means the node just is busy, the CPU is busy,
Yes.
or something.
I cannot answer on time.
And so it asks you to, I mean, one possible reaction to this is just to ask it later on.
Yes.
And in the second case, it is, I have node A that has requested me 3 cells, and node B requests me 3 cells as well, but it overlaps.
Yeah.
So I cannot make a decision about node B as long as the decision from node A hasn't been finalized. So this is really a cannot handle, by construction, I cannot handle concurrency on these cells because they overlap. So, okay, so the idea of chain is to take a bit, so have a metadata field that is not null, and from that bit, kind of subdivide the 2 cases from the same error code. Would it not be easier to just add an error code?
We discussed that, and we said on the mail list, and
Okay.
that happened to be no.
Okay, there's consensus. Okay, thank you.
So is there in the specification an actionable difference for the requester when it gets this error code? Do I do something different if the bit is on or off, or it's just for information?
No, that's a proposal. We haven't implemented yet. Okay,
But in the specification at the end of the day, you must say there is this written code. What you do,
Yes.
and would you do something different if the bit is on or off?
Maybe what was proposed on the mailing list was to put different timeout values.
Okay.
What to do now? Okay, so first of all, we are going to adapt to the scheduled generations from 6P, which is the new feature, and of course change the behavioral boot because we want to recover from a crash or disconnection. Then we are working on the self-server location, which we have proposed a 20% of difference below the average packet delivery rate should trigger a relocation, but we don't know if we want to propose, okay, this 20%, but it's arbitrary now. Okay, we don't know if there are some measurements simulation which support some other value which could be added here. And the thing is, since this should be triggered periodically, maybe, okay, so if we have to measure it periodically, the thing is which should be the measurement period for this process. Or if you have to specify this or not, maybe you have to leave to implement it, and that's it. Then, okay, the thing is the timeout to delete the cells. The thing is here, it should be larger than the time it takes for a node to recover. Okay, that's an important point here. And since we lose a neighbor, okay, when are we going to erase those cells? Okay, or to us to erase those cells, or to free those cells. And then and there's a limit case, and when are we going to decide to erase cells because we don't have any more cells to distribute among neighbors? That's another question. If we do take into account that condition or not also. And that's it. Okay. Any more questions?
This is Tengfei from INRA Paris. I have a question about the Vienna-wise estimation algorithm.
Yeah.
And because it is saying with some situation to add cells or remove cells, but it says add one or more.
But the estimation there, the estimation or the allocation policy. This is the estimation algorithm. This allocation. Okay.
Yeah. So it's delete one or more or add one or more. How I decide add one, or when I decide add more, and what's more means how to calculate the more cells. So I'm not clear with that.
From my point of view, that if the required cells are more than the thing is are more than currently scheduled cells, we add the difference from one to the other. But if you have some other proposal to increase faster because you are looking for the queue and the queue increases the queue length increases very fast, then you should add faster. I don't know. For the point time being, what you have calculated only is to add the number of the required cells on top of the ones of the scheduled cells, meaning that the difference between them.
Yeah, as an implementer position to say that is no clear. Is it better to have something to say how can I calculate this? Because
okay, the difference. Okay, that I think was written. Okay.
So, any more questions? So I have two general remarks. One is just to place this work. This is essential work. We see SF0 as being kind of a minimal scheduling function, something that just to place this, we can have many different scheduling functions, and SF0 is meant to be the simplest one, kind of a generic one. I'd love to see some. I mean, you propose something and makes sense, but it would be great if we could have some implementers maybe, of course, implement it, but also give us some feedback about its performance.
Okay.
To convince the working group that this works in a typical case. Take at the beginning of Roll, we wrote those 4 drafts with requirements for different types of networks. Can we run networks using this in those different configurations? Can we bring back some confidence that this is the right approach? Or that's one remark. I don't know if there's already work ongoing that, it could even be simulation. I mean, something that allows us to have some faith that this algorithm will give us what we want. And the second remark is there will be a presentation of SF1. And we don't have to answer it right now, but the people presenting SF1, I'd like you during your presentation to really place SF1 with relationship to SF0. Is SF1 better than SF0, or does it answer something completely different? Because if you think it's better, then we'll have to make a decision on which one we pick, how do we merge them, etc. If it's completely different and it answers a completely different use case, then I'd like to understand exactly how this works. So we don't have to answer this right now, but let's do this during the presentation of SF1. Thank you. Any further questions? Thank you, Diego.
Well, we need to decide whether the initial bunch of cells that SF is playing with, how this is obtained, is to be discussed in this draft, or if it's to be done somewhere else. Because if you're doing this ripple network with 5 hops, the nodes very close to the center will need a lot of cells. The nodes which are at the very edge will need very few. And so unless, you can imagine that manually you go, where you position it, so you give more cells to the guy which will be near the center.
Yeah.
That looks weird, right? So that seems to call for a processing to get the number of cells to play with, which is different depending on where you are in the network.
Yeah.
And that needs to be described somewhere. So if it's not SF0, then maybe we have a work item there that needs to be covered. Because basically you're asking the question, how do I know what to do when I don't have cells anymore? And that comes with the question, how did I get the cells I have in the first place?
Yeah,
Right.
that you need a minimum number of cells for as a supply to get doing bootstrap.
The minimal number of cells for a node which is near the root is not the same at all than what it is for a node which is far from the root. So
which would be how to calculate that number given the depth on the.
I'm saying there's probably a piece of work which we have not done here.
Okay.
And I'm just saying maybe it's this draft, maybe somewhere else, but there needs to be a way to get those cells in the first place.
Okay. Last question, please.
So Xavi Vila Josana. So Diego, in the last slide you had it.
Sorry.
Yeah, don't worry. So you say that you want to detect when the node is busy because it's in a concurrent transaction, or when the node is busy because why you want to differentiate both cases? In both cases, you will retry, right?
I will try, but I think we will try later in the case that the processing is overloaded node. Maybe the other I should wait till the next cell because I expect that this is going to be solved on the next step.
So it's just a matter of a timeout.
Yeah, different timeout.
Yeah.
Mm-hmm. Thank you, Diego. We're running a couple of minutes late. Thank you. Michael will give us an update on the work of the security design team. You can tell me next slide.
Hi, am I in the pink triangle, rectangle? Next slide. The security design team started with a set of calls starting in early 2014 when we were not even chartered to work on security. This was to try to make sure that when the time came, we knew what we actually could accomplish and what we would do. If you're a part of that, thank you very much. That was very useful, and it was also meandering. So we have rebooted starting in May 2016. After some difficulties picking a time that worked, we have settled on Wednesdays at 1400 UTC, and we're meeting by Jitsi primarily, which does not have an option to dial in by PSTN, unfortunately. But it does work almost everywhere that computer-mediated stuff works. And we tend to work with the Etherpad and voice and talking about what's going on. So we've started a draft, a GitHub. It's in Cramdown, which I've never used before, but seems really fun, and you should try it. Thank you, Francesca, who suggested that. And the 00 was going to go out this morning, but is not yet left my laptop. And it will contain mostly an introduction and a table of contents, which I'm going to talk about here right now. Next slide, please. So this more or less is the table of contents that we wrote down as an overview of what we're going to do. We talked a lot about whether we could afford to have a problem statement, whether we could afford to not have a problem statement. The conclusion is that we really don't want to have another document, and we don't want to go that way, but we really do need to explain our motivation for what we're doing and a set of assumptions and restrictions about where we're going. And so that's going to be the introduction of the document. And I'm just going to talk briefly in a moment about that. But following that, we're basically talking about a protocol who aims to be bandwidth conservative, that allows the join coordination entity to control the order of the joining such that it isn't a stampeding of elephants that eats all of the bandwidth, regardless of what we find SF0 and SF1 people will do to give us a little bit of bandwidth for joining, but not a lot. And then the other question that we have is essentially code reuse, and the code reuse problem essentially comes down to we don't want to have any security protocols that aren't being used for some other reason. So if we have security code that is only used for Bootstrap, then the odds of it being correct, maintained, and that someone will actually successfully argue for including it in their limited budget of code space is probably small. So this means we're looking at what is the application layer going to use above you. And if you go over to talk to the core working group and the ACE working group, so it's all CoAP. So that seems like a given. And then the question is it DTLS plus CoAP? Or is it object security CoAP? And object security is not exactly a key agreement protocol at this point, but Joran will explain to you that, of course, we have this thing that he's named ad hoc. So ad hoc, but with an E. And it looks really exciting. So with the goal of not reinventing IPv1 and TLS, and yet actually not necessarily reusing them, the question is how that is going to progress. And that's not going to happen in this working group. But what I hope is we're going to actually feed some information elsewhere. And I'm not really clear where OS CoAP work is going to happen at this point. And I'm not sure, Goran, you're clear either where that's going to happen. So maybe you'll speak to that. So just before you do speak to that, I wanted to say a little bit about some of our assumptions. We've got a lot of pushback on doing zero conf. So that would mean that you can drop ship the devices to some place and they will magically come up without having to touch them before. There's a lot of people that like to have this, but a lot of people worried that that is too expensive and that it is perfectly acceptable, and you should feedback on this, for every device that you intend to deploy to go through some provisioning room or thing where someone actually touches them and does something and then puts them back into inventory. So what we're trying to do is have a process whereby the zero-touch process essentially allows you to get to the one-touch step, or you can start at the one-touch step if you didn't do that, but that the rest of the network protocol when you deploy it looks the same. So this table of contents is absolutely not set in stone. So I would very much like it to get feedback on whether it fits, whether it answers questions that you have before we actually fill in text that is useless, or maybe there are sections that you think are useless. And Joran, go ahead, please.
Okay, just comment on where OS CoAP and that
Name,
belongs.
Pardon me?
Joran Selander Eriksson. So those are application layer security protocols, and they are built on top of COSI. So COSI is now in working group last call. OS CoAP has been around for 2.5 years.
Okay.
And we will ask for adoption in core on Thursday. So
Okay.
everyone is very welcome there to express their views and provide their input. And ad hoc is less clear where it will belong. It's essentially doing Diffie-Hellman on top of COSI. So that a security working group would be the right place. And basically, it's in COSI, there is already Diffie-Hellman ephemeral static and static static. So we're doing something ephemeral, which makes it a two-pass protocol. And that's going to be presented in the ACE working group this week. Okay.
Good. And again, the point here is that not to use a protocol, a key agreement protocol that doesn't already have a reason for being in the devices. That's the goal here.
Right.
And so I have no preconceived notions about what it should be. I just want there to be one, and I have lots of experience with people saying, "Well, I don't have space for that."
Yeah.
We'll just omit security. We don't have space for that.
So that's a good question. So the reason why these would be interesting from that point of view is that we expect the COSI would be somewhere in your code anyway.
Right.
Because you would use it for access tokens, you would use it for wrapping keys, or you maybe use it for firmware updates, which is also natural to have as an object security-based mechanism. So given that you have COSI already in your code, these are minor additions.
Yeah, Carsten Bowen, mostly +1 to what Jörn said. So the COSI working group may or may not stay around after having finished its current main task. But I think the assumption is that we will have a place to do this kind of work like
What is COSI, just for some people in the room?
CBOR object signing and encryption.
Thank you.
We have been defining a message syntax that just completed working group last call. There are a few drafts out there right now, mostly around algorithms, and ad hoc is an algorithm.
Right.
So depending on whether we develop this pattern of doing these algorithms drafts in COSI or somewhere else, but we will find a home. I mean, in the end, we can use ACE. So there's enough IoT working groups in the various areas that we can get this work done.
Right. The key is to avoid the mistakes of TLS and IKV2 while not throwing away the good design patterns that we have developed over many years, and that I think is the important thing. So I'm done. Any other questions? I hope at the next IETF it'll be very exciting and you'll be last calling documents. So thank you.
Thank you, Michael. Next item on the agenda is, if I can find it here. So Miguel unfortunately had to take the plane this morning, but Margarita agreed to jump in. I can switch, it's fine. Thank you, Margarita. So it's a report on the 6TISCH low plug test that took place this weekend.
As Thomas said at the beginning.
Oh, microphone.
So we had during the weekend a 6TISCH low plug test, and it was organized. No. Is it better? Okay. So we had the 6TISCH low plug test. It was organized by HC, and it was supported by OpenMote and OpenWSN that provided the hardware, the detail, the golden device, and the firmware. And this event was sponsored and funded by the European Commission. We had 15 companies that participated. We had 8 different implementations, and there were 3 companies that were only observing. Here you can see the agenda. It was a 3-day event. We started on Friday. We did the setup during the morning, and we had the first test session during the afternoon. And on Saturday, we could test during the all day, and we ended yesterday with the teardown session after lunch. before the event, of course, there was, as usual, a preparation, and then we had an initial call of expertise, and there were 4 people selected, and we were Thomas, Chavi, and Tengfei, and myself that worked on the test description for 6TISCH, and the company had the chance to participate to a call during which we presented the test, and we could discuss with them about the configuration and the test that should be performed. And here you can have just an overview of what has been ongoing in these 3 days, a lot of cable, sensor, device, and a lot of tests.
So as the picture suggests, this was a wireless interop, huh?
And actually offer us this test report tool, which is used for scheduling the different test sessions and for reporting the results that now I will shortly summarize. So in terms of tests for 6TISCH, we had 20 tests, and these were classified based on the feature that we wanted to check, and in detail we checked the minimal schedule for the synchronization, we checked the security for the authentication and payload encryption, we checked together the 6TISCH protocol and scheduling function 0, and we had also some tests for 6-low range and the backbone router. So in terms of feedback and lesson learned from the test, Charlie had already summarized the outcome of the event. So we have identified several aspects that need to be fixed in the 6TISCH protocol, in detail the 6P count that should become a 6P status, so we can take into account both the transmit cell as well as the receive cell. We should use some pagination for the 6P list, taking into account when we have long list, and there should be a mechanism for making sure that both neighbor nodes that are communicating have a consistent schedule. Then for 6-low NFC, we had 80% successful interoperability test, and they realized that there is a need of having maybe a 6-low gateway and a packet mapping mechanism. And for the BBR backbone router, we had 66% interoperability successful test, and also in this case the test was useful for identifying some improvement to be done in the draft related to the status code in the ARO option and host route in the router, and some of the tests were not successful because there were some issues in the implementation that will be fixed for next time.
Margarita, if I may, so 66 doesn't seem good, but most of that is because we could not run the test because of the, well, mostly hardware capabilities. Well, some things were inside the box, but we could just not connect them for some reasons because of the hardware chosen, etc. So it's not that it doesn't work, it's just that we could not test it. But most of what we tested actually worked. Right?
And so, as it should be clear, the event was quite successful, and we had the chance to implement in real what we have written in the draft, and also to understand what we should improve in the next version. And in terms of general feedback for the plug test itself, we feel that maybe instead of coming and just start with the test, it should be nice if we can have a pre-test session where people can meet, discuss, have an idea what they are doing before starting the testing, and then for having more participants, we should advertise the event more in advance. And that's it.
Thank you, Margarita, for jumping in. Any questions about this? Okay, we have discussed with Miguel the possibility to have a plug test in 2017. We're debating whether it would be good to have it in February outside of the IETF, somewhere in Europe, or in July in Prague. So we'll know very soon. The idea is to know soon, so that we have at least 6 months of runway.
And we are very grateful once again with the ETSI and with Xavi and Margarita for organizing this event, which was a great success and helps a lot in figuring out the bugs in our specs and in our code. So we really have a very good model here going through new text implementation, ETSI plug test. So that's really valuable. Thanks again to the ETSI organization.
So we entered the last 15 minutes, and we are now in non-charted items. So Satish is going to present SF1. Satish, you can say next slide and I'll switch.
Very good afternoon to one and all. My name is Satish. I work for Huawei Technologies Beijing. The title of this presentation is Scheduling Function 1 for hop-by-hop scheduling in 6TISCH networks. Next slide, please. Why do we need SF1? Currently, we have SF0, which is an one-hop scheduling protocol that is mainly used for aggregate traffic flows. I mean, like whenever the different kind of traffic flows are there. Okay. Yeah, different traffic flows are using like same cells to transmit the data in between node A and node B. The first figure is for aggregated traffic flows, where SF0 is mainly works for dynamical cell adaptation for one-hop scheduling, which is best suitable for, best effort traffic flows. But there are some applications like kind of real-time applications where we need to have like time-critical traffic flows. That is like the end-to-end, we need to have some kind of dedicated scheduling to transmit the data. For that, we propose an scheduling function 1, which is called an end-to-end scheduling protocol that will schedule an isolated traffic flows. The meaning is like the whatever the traffic that is going to transmit in between source and destination in that figure, where dedicated cells are used to transmit the data. The main objective is to support the time-critical traffic flows. Yeah, for this, we need to have some kind of end-to-end reservations with scheduling capability. For that, currently we have like two kinds of label switching, reservation with label switching operations. One is through RSVP MPLS, whereas another one is like an implicit labeling switching. But the architecture draft, 6TISCH architecture drafts mainly recommend to work for implicit labeling. So we propose, for that, we come up with a new kind of capability called cell switching capability, where the cells are used to forward the data, to switch the data at the 6-stop layer. Whereas for Sonnet or some kind of Ethernet, we have already some kind of switching capability. But for 6TISCH, we propose this kind of cell switching capability to forward the data from source to destination.
Excuse me, can I just, so what you're describing here is something that we've talked about at 6TISCH since the beginning that we call a track.
Yes, yes.
Right? And so there is already in the architecture some work which has described how a track is indexed. So how we find like this GMPLS thing you're talking about, but also that we still have some tags inside the packet, if it's an IP packet, so that we can figure out which track it should be in, so we can correlate the track and the cell. Even if we don't need it, we will find it, and it's all described already in the architecture. So if you want to discuss that, if it doesn't work for you or something, then there needs to be a discussion about the architecture.
Okay.
Right, all this, because you're not really discussing here a scheduling function, you're really discussing a protocol to install a track in 6TISCH.
Yes, yes, yes.
So that's a lot more than just saying how many time slots for something. It has to do with what is my setup protocol for this path.
Yes.
What is a path? What is a track? So that boils down to very deep things in 6TISCH. So work was done already, and you need to refer to that work. And if it doesn't work well, then we need to go to the architecture level for this.
Okay. Next slide. Yeah. The objective of, sorry.
I'm sorry.
Before slide.
Is it okay?
No, before one.
Sorry.
Yeah. Objective of SF1 is when to reserve the end-to-end resources. Like whenever there is an application transmission from source to destination, then the SF1 has to trigger the RSVP protocol along with then scheduling capability and label switching. Then later is how to provide implicit labels for the reserved resources. Later, when to schedule end-to-end L2 bundlers to transmit the data, and then how to associate the track IDs for the for the selected cells to transmit the data. Here in this case, we work from extension of RSVP, RFC 3473. We try to extend this protocol with try to provide scheduling capability for this resource reservation with GMPLS. Since the RSVP protocol, the basic RSVP are the extensions treat other protocols as an objects. We select the scheduling 6P protocol and scheduling function 1 as an objects in an RSVP protocol. Here each cell, the channel offset plus slot offset is used as an implicit label, whereas in RSVP also the label size is 4 bytes, so we can directly use this cell as an label to provide labeling from destination to source to transmit the data. Here assumption is end-to-end route path is assumed to be available. Here we already assume that the path is available in between source and destination. So we are trying to reserve the resources. At the same time, we are trying to provide the scheduling capability to forward to transmit the data. Next slide. Yeah, this is then some kind of example we have taken to explain the end-to-end operations. The source is here the path messages. Whenever the data is there, the path message is initiated with an extension of label request called cell switching capability. Whereas we are trying to check, we added these two kind of objects called SFN operation request, at the same time 6P operation request. Like once the path message is being transmitted from source to destination, the intermediate nodes will check all the supporting, the service request. If the intermediate node cannot support scheduling functions or cannot support 6P operations, then it can send some kind of path error message back to the source, so that the source can try to find out the new path, or source can try to make use of best effort traffic flows to transmit the data from source to destination. So here in this case, we added two kind of objects called SFN operation request and 6P operation request. Whereas RPL instance ID is added in the sender template. In sender template, we usually have the port IDs and source IP address. Whereas we added RPL instance ID also here to create the track from destination to source for track forwarding. Next slide. Yeah, here this is from reservation. Here, since the RSVP is an receiver-oriented protocol, we try to provide scheduling from destination to source. In the sense here, the source is like a parent, whereas destination is like a child. Since the source is going to transmit the data from here to destination. So now the destination is, since the destination is a child node, we make use of 3-step transaction. If the destination is like a parent, then we can make use of 2-step transaction to reserve the resources to provide labels, and at the same time to schedule the cells. Here in this case, at first the destination will check the service request specification, and it will check for the reserved bandwidth, check required bandwidth. Later it reserves the bandwidth. Then next step is the scheduling function 1 will convert the reserved bandwidth to exact number of cells, received cells here in this case at the destination. Once the cells are reserved, then the reserve message with 6P request is, along with track ID is transmitted to node B. Once the reserve message is reached to node B, now node B will again process the reserve message. It will check the service request specification and reserve the bandwidth at node B. Once the node B reserve the bandwidth, then SF1 at node B will try to map the cells, map the bandwidth to transmit cells, because it needs to transmit the data downstream. Here we are trying to send the message, reserve message, like some kind of control message, upstream, whereas the data will be transmitted in downstream. That's why node B is trying to create map the SFN of node B will try to map the bandwidth to transmit cells. So here in this case, once the SFN map the cells, bandwidth to transmit cells, then it will send the 6P response with cell list. Once the 6P response with cell list is reached to destination, now destination will confirm whether if the cells are available, then it will confirm. At the same time, the label request will be, the label set will be created for the cells that are being used in between node B and destination. Here the main important point is the 6P request from destination to node B, the 6P request is trying to receiving cells, not transmit cells. So this point is most important. In 6P presentation just before, I saw in 6P add a request, the cells are trying to reserve for transmit cells. But here in this case, we are trying to receive cells. So this is there is some kind of conflict in between 6P protocol and here in this. Okay, sorry. Here once the 6P confirmation, once the 6P confirmation is received from destination to node B, now node B will do the another same procedure. Next slide. The operation is same here, whereas the node B incoming interface will send the same message to the source. Now source will reserve the cells once the cells are available. Next slide, please. This is two-step transaction. In where two-step transaction, the label set, once the resources are reserved and the scheduling function is mapped the cells to reserve cells, the labels are created at the same time before sending the 6P request. This is a two-step transaction. If in the case whenever the parent wants to reserve the cells, in that case we can make use of this kind of operation. Next slide, please. Yeah, this is from node B to source, the same operation. Next slide. Yeah, this is exactly, data transmission. Once the resources are reserved, labels are provided and cells are scheduled, then the exact data transmission is explained in this slide. Whereas the IP with data packet are created, are generated at source node. Once the packet is reached to 6-stop, the track ID is already generated for the cells. Based on the track ID, the data will be transmitted to the next stop. Whereas at 6-stop, the track forwarding is used to forward the data. So here in this case, the same concept, the L2 bundles are used to transmit the data from source end to end, whereas source or destination IP address with RPL instance ID is used to identify the track informations, whereas incoming cells are labeled as it's labeled with some kind of cell labeling to switch the data at 6-stop in between the intermediate nodes. Whereas destination MAC is set as a broadcast, whereas so that once the data is received at node B, the node B will not process the packet. It will directly find out the next track, and it will switch to the next track to transmit the data towards the destination.
You need to conclude them.
Yeah, yes, complete. Next slide. I think yes, complete. Questions, please.
A short comment is, just like I said, this is a lot more than just a scheduling function. This is a path setup functionality for which we are not chartered. We discussed in 6TISCH from the beginning that one day we'd like to work on it. So probably, hopefully, we'll be chartered one day soon to be working on this. So it's good that you work on it. It's good that you start to work, but be very clear, we are not chartered to produce this document, right?
Okay. Yes, in architecture draft, this clearly mentioned the the GMPLS with some
yes,
kind
we
of.
want to work on it one day, but our charter currently says we work on security with what Michael is doing. We work on SF0, work on 6-stop, and that's pretty much our charter item. Okay. We need to recharter to have some work like this. But you can work on it. The group is interested in this work. Continue. Let's move forward. But okay. Yeah. So be prepared that we can't adopt the document now, right? Okay. It's very clear.
Yeah, I have two questions. I'm Lijo Thomas from CDAC. Can we use this scheduling function for creating a deterministic network? Because already you are using this scheduling function. Yeah.
Yes, of course, this is for deterministic network. Yes.
Okay. So how you will ensure that the time is bounded? Because
time bounded.
Are you?
No, still
okay. So, my second is, did you have any plan for the track ID lifetime? Because how much time you are going to allocate this track for the particular?
We have some kind of refresh messages. Okay. Based on that refresh messages, if the refresh message is timeout, the track ID will be automatically deallocated.
Okay. Thanks.
We need to stop after Chavi. Thanks, I'm sorry.
Okay, so very quick. There are many papers around this thing about label switching on 15.4. And then they explain similar things than you are presenting. Second is you propose a cell-based implicit labeling. Why not time slot directly? If in a time slot you can only receive from one channel, so a listening node in a time slot can only receive from one channel. Why you want the channel as well in the label? The time slot is enough, right?
Okay. Yes.
You have a single radio.
And then the last point is in the label. Then maybe one thing to consider is the slot frame ID. in case you have more than one slot frame.
So, yeah,
Frame ID, okay.
I suggest we take this on the main list. That's okay. Thank you very much. Thank you for presenting. So the last, we're 1 minute to go. Anybody wants to bring any other business that we haven't covered before we conclude the session? Let me bring one up, little advertisement. There's an info session tonight, 8:30 to 9:30 in Charlottenburg 1, about a project called FNTROP, which is a system for remote conformance and torp testing that we're putting together with a bunch of partners. We'll be describing what it is, give you a live demo, and ask questions. Is useful for IETF community. There's an open call as well, so if you're interested, 8:30 Charlottenburg. Any other business? Thank you very much. With this, I close.
Everybody has signed the blue sheets? Blue sheets, everybody signed them? Please bring the blue sheets here.